Very good afternoon to all students. Welcome to the live virtual classes organized by the Board of Studies Academic ICAI. Today we are going to discuss the last part of Unit 2 of Chapter 14 on the measures of dispersion. So, good afternoon, sir. Sir is here with us. So, sir, if you want to please share any observation or any, sir, tips for the students.
Sure, sir. Good afternoon, sir. Welcome to the live virtual classes organized by Board of Studies Academic of ICAI. In the last session, you must be covered about the initial stages of the part of the range and quartile division.
Mean division. So mean division we have done. Today we will do standard deviation and quartile deviation.
Okay, that's great actually. In the last section, sir has covered the range and mean deviation, which is also very important. And about range, what is the properties also be. And when we come to the important aspects of the range, quartile deviation, mean deviation, and standard deviation, all are familiar with these concepts also. That is, the range is affected by change of scale factor only, not origin. Suppose y equal to a plus bx, a is origin, b is the scale factor. That is, the coefficient b is the slope or intercept, or like we can say in the mathematical terminology in the various terms. Range is affected by change of scale only. Mean deviation is also be affected by change of scale only. Even quartile deviation also be affected by change of scale factor only, including standard deviation also be. From this angle, one question would be coming in the examination. Generally, if you prepare like that also be very, very important aspect. Range is mostly used where it is used quality control to understand the changes in the climatic fluctuations also. What is the lowest temperature, highest temperature, even in the quality control also be range is mostly used also be. Even when we talk about the mean deviation also, mean deviation is computed from the mean, median, and mode as well. But among them, mean deviation is computed from the median is the best measures of central tendency. When the classes are taken from, or like data is collected from the open-end classification, that must be would be explained in the last class also very well. I know he's a very good teacher, no doubt about it. I learned many concepts from his good voice also. Sir is having very good voice model culture also. I we congratulate him actually. For him is a very good, nice lectures. Students would be also benefited with this. They need only thing is concentration and focus on the sections are also be. Once you focus on the section and you will be self-motivated. The course is very simple and easy also be. The concepts which are given in the study material also, basically it is covered very basic knowledge of the statistics part only be, which is essential for the chartered accountant also be. Further, we are moving into the section like today's section is the about the measures of central tendency. In that actually quartile deviations actually. Yes, in the quartile deviation, how the data is divided into the 1/4, 3/4, and middle. Based on that, quartiles has been fixed. From this quartile deviation and the difference between the upper quartile and lower quartile by 2 also be. Coefficient of quartile deviation is Q3 minus Q1 by Q3 plus Q1 also. These are the important aspects. Again, we move to the other angle. Important thing is the standard deviation. Standard deviation is, in the simple terms, we can say that It's a root square mean deviation also be. Symbol is sigma. The rest of the properties are combined deviation. What is combined standard deviation? And the other aspects are also be given. In the study method, if you look at uh, about the continuous series, means class interval data are given also to understand the general knowledge purpose only, practice purpose only. In the real sense, in the examination point of view, such questions are taking very length time, and it takes time to consume in the exam also be. We have to understand the general scenario of these questions and how it can be used also be in the general aspects also be, and keeping in view of the time and other important things, general overview of the topics also be, and importance given to weightage for these topics are also be as much important. What are the general limits and means in terms of the permit limits means contained to the subject point of view I'm talking. um, we have to be constraint, time constraint also be important. So you have to concentrate on that. Sir is taking good number of questions in that. I must be congratulate him. Thank you for your good lectures, sir. Also, only request to the students is you have to focus on these sections, and which is very important. This 40 marks chapter that was given to the allocation to the Arjit Chakraborty sir, and 20 including logical reasoning also. Major weightage also be given to his head. Students, once you are focused on these chapters are also be, you will be definitely pass in this examination also be. This is my just interpretation about this topic also. Further, I had given the brief introduction about this. Welcome, sir, once again.
Thank you, sir. Thank you, sir. So very good afternoon to you, sir, and thanks once again for sharing deep insights on the explanation to the students, the essence of each of the types of the dispersion measures which you have so nicely explained, as well as the tips and suggestions regarding, I hope the students will definitely follow your advice of focusing, concentrating, understanding the concepts. And as sir has said, dear students, that all the tools and the methods of dispersion, starting with range, mean deviation, and then of course today we are going to cover in details quartile deviation and standard deviation. If you see, these are not just important measures of dispersion, but it is a very good way to understand the variability in data. And in the last session, if you see a quick recap, we had been discussing about the concept of dispersion and how it is different from the measures of central tendency. And as sir was mentioning, that these concepts are simple as well as scoring. Plus, most importantly, if you see, these have a lot of practical applications in finance, in accounts, in other branches, other subjects and domains, which you will study in course of the journey in your CA, in the CA intermediate and final level. So central tendency locates the center of the data, but please remember that dispersion measures this, how scattered the data is and how variable, what is the degree of variability of the data with respect to the center or with respect to the middle value. So that is dispersion. And in the last session, the part 1 of unit 2, we had explained in details the concept of range, mean deviation. Please do recall, dear students, that the measures of dispersion, you know, are of two types. We have the absolute measures and the relative measures. Range, mean deviation, quartile deviation, standard deviation, these are examples of absolute measures. As a result, you have the units, maybe in rupees, in meter, or in any other physical unit. And the relative measures are used when we want to compare and contrast between two sets of distribution. And there you will definitely remember that I was mentioning that whenever you see the word coefficient, it is a signal that this is a relative measure. Accordingly, we had done a number of problems on the coefficient of range, and sir was kindly explaining all those important tools, including the formula. So this is for your recap. And please also do remember the coefficient of mean deviation. Usually it can be done. The mean deviation can be calculated from the mean, from the median, or from the mode. But you will find, and as we had discussed in our last session, that the mean deviation, when the deviations are measured from the median, it gives the minimum value, right? So these are important tools and concepts. And today we are taking up the understanding of standard deviation first. It is the most important measure of dispersion, and we shall see why standard deviation is regarded as the most practical and the most often used measure of dispersion. So we will go through the concept, we shall understand the formula and the important properties of standard deviation. Along with that, just as we have done in case of the previous measures of central tendency and dispersion, we shall try and understand the advantages and disadvantages of standard deviation. And then the last important measure of dispersion, that is the quartile dispersion. The quartile deviation, we shall look at the concept, formulas, properties, and then on the relative measure side, we will take up number of problems on the coefficient of quartile deviation. MCQs from the exercise are very important. In the last session, we had covered and explained number of problems. Today as well, we will take questions from the MCQs of the ICAI study material, Chapter 14. We also have number of questions from the AQB, the additional question bank, which is given in the CA study material. And thereafter, we will go into the MTP and the RTP questions. So now we move into the understanding of standard deviation. So you can see, as the name suggests, mean deviation, standard deviation. So deviation means dispersion, means scattering of the data. So standard deviation is what? It is the root mean square deviation when the deviations are taken from the arithmetic mean of the observations. So if you look at the slide 14.2.4, and you can see the exact formula of standard deviation is given. That mean deviation, the study material says that although the mean deviation is an improvement over range, see, range is very basic. Range is very easy to understand, easy to compute. So range is also seen as the most easiest, I would say the easiest in the dispersion category. Out of the different measures of dispersion, range is the most often, really it is easy to understand. It is very simple to compute. So mean deviation is an improvement over the concept of range. But then we have seen that mean deviation has certain disadvantages and limitations. The best measure, please see the study material clearly mentioning that the best measure of dispersion is usually the standard deviation. Why? Because it does not have the demerits of the range and the mean deviation. So as you can see here, the standard deviation is the square root of the summation of the square of the deviations. As you can see, sigma xi minus x bar whole square divided by n, and we take the square root of this to derive the standard deviation. And we shall see that the standard deviation has number of practical applications. The square of the standard deviation is known as variance. And in the remaining chapters in statistics, you will find that standard deviation and variance, these are used. These have a direct applications in many of the remaining chapters. Plus, importantly, if you see standard deviation, it is having most of the important characteristics of an ideal measure of dispersion. That is why standard deviation is regarded as the best measure of dispersion, and it has a wide use. And as you can see on this slide, the variance is the square of standard deviation. Please remember, standard deviation is denoted by the letter sigma. And many of you are aware about the term Six Sigma. You might be knowing that this is a process of quality management, total quality management, quality control. And there, Six Sigma is an international best practice. And there again, it deals with reducing the deviations. So therefore, you can see even in the world of business, commerce, industry, there are practical applications of variance as well as standard deviation. So variance is the square of the standard deviation. And from here, so standard deviation is the positive square root of the variances. That means we can easily understand that standard deviation, is it a relative measure or is it an absolute measure? So standard deviation is always an absolute measure. And as you can see on the right-hand side of the slide, standard deviation is the best method of dispersion, and globally, it is the global standard, even in scientific research, even in machine learning, advanced data modeling. That is the reason why standard deviation is regarded as the best measure of dispersion. So the formula is, as you can see, it's given here, sigma xi minus x bar whole square by n, and we take the positive, the square root of this expression. From here, you can see there is a relative measure which we are able to calculate, and this is known as the coefficient of variation. So formula 14.2.8 and 14.2.9, which has now come up on the slide. So you can see these are from the study material. So please go through this formula, remember the formula, because we shall be using these for different types of calculations. And as you can see, the coefficient of variation is connecting the standard deviation with the arithmetic mean. Now, standard deviation is a measure of dispersion. Arithmetic mean is what? It is a measure of central tendency. Together, you can see the coefficient of variation integrates, it brings both these two measures together in the form of a ratio, in the form of in a formula. It's like a fraction, and you multiply it by 100 and you get the percentage of the coefficient of variation. So you might remember, dear students, that this is an example of relative measure of dispersion, and very similar to the earlier concepts of the coefficient of mean deviation, coefficient of range, right? So then we see the next part. That means standard deviation, we have gathered that it is the most important, often used in not just in finance, economics, or accounts or audit, but variance, even in portfolio management in the area of stock market returns, portfolio of investments. This is the gold standard. Variance is always calculated across the industries. And in the last session, I was discussing the practical applications of the method of dispersion in different sectors of economy in the world of commerce and business, right? So now let us see the first example from the ICAI study material, the illustration, where you can easily understand how standard deviation is calculated. So kindly see and focus on the first example. There are 5 numbers which are given. We need to find out the standard deviation, plus we have to calculate the coefficient of variation. Please remember, students, that the coefficient of variation is a relative measure. And as you can see from the formula given on the slide, coefficient of variation is the standard deviation divided by the arithmetic mean. That means the coefficient of variation is adding or is bringing together one measure from the dispersion and one tool or one measure from central tendency. Now, looking at the calculation, xi, you can see in the table, we have 5, 8, 9, 2, and 6. These 5 numbers are given. And on the next column, you can see the xi square. That means we are calculating the square of each of the numbers. We have 5 square is 25, 8 square 64, and so on. And then Sigma xi, that means the sum of the given observations, is also calculated, which is 30. And from here, we can see that the first and foremost, we will see that the standard deviation is calculated. And this is the most basic formula of standard deviation. You can see there is no classified data, there are no classes, just individual observations. And therefore, we arrive at the standard deviation. Sigma xi square, which you see is 210, and we divide it by the number of observations, and that is equal to 5, n equal to 5. So 210 by 5 minus 30 by 5. That means sigma xi squared by n minus sigma x by n whole square. Right? Please see these two. I'm just moving the cursor. 210 by 5 minus 30 by 5. This is sigma x whole square. And we take the square root of this, we get 2.45. So this gives us the standard deviation, which is measured by the letter sigma. Now the coefficient of variation is the standard deviation divided by the arithmetic mean. So now we have these numbers 5, 8, 9, 2, 6. The arithmetic mean comes to 6. So therefore, the standard deviation divided by the arithmetic mean multiplied by 100 gives you 40.83. So this is, you can think of it as a percentage. So this is a relative measure. The coefficient of variation is a relative measure of dispersion. Now we look at the next example, 7, 9, 16, 24, 26. So we will try to see how the standard deviation is calculated for these numbers. And as Sir mentioned, these are very important for you to understand the process. These are a bit lengthy, and maybe for the exam, these type of problems may not come in the exam, but these are important for the understanding. So you know step by step, conceptually you are clear that, okay, I have xi, different values of the observations. I will get the sum of that, sigma x. I will also go for squaring each of the observations, x1 square, x2 square, x3 square, and therefore I will also obtain the sum of the squares, that is sigma xi square. So this understanding is important, and from this table we will now see how we are arriving at the standard deviation. There are two processes taken. First is the deviation is taken from the, you can see, from the sum, and the second one is the deviations are taken from the absolute, the assumed mean. Now here, first one we can see, first is we are taking the deviations from the, first is the AM, so assumed mean we are taking. Now we have assumed mean. Let us take the assumed mean here. We will take, let's see we first calculate the assumed mean here. We will take it as 16. Now, in the method B, if you see the right side column, the deviations are now taken from the assumed mean. And here we are taking 16 as the assumed mean. Therefore, the deviation, what is the formula for deviation? Xi minus A. So xi, the first observation, please see, is 7. 7 minus 16 gives you minus 9. The next observation is 9. 9 minus 16 gives you minus 7. And so on. We are getting now the column of the deviations. But please note, these deviations are from the assumed mean, which is 16. It has been taken as 16. Now we do the square. We calculate di square. And therefore, we get we square each of these numbers, and then we get sigma di square, which is 294. Now from here, we can first, what we can do is, we can find out the standard deviation. If you look at the first method A, which is given, now here from method A, if you see, there are numbers which are given. If you see, there are 5 numbers, 5 variables, 7, 9, 16, 24, and 26. Now from method A, if you just calculate the mean of these numbers, the arithmetic mean, you just sum up all the numbers and divide it by 5. So that is the process of computing arithmetic mean, and it has come to 16.4. So therefore, taking this particular step, so now we know that the actual mean is 16.4, and in the second table we have assumed that 16, the assumed mean is 16. So looking at both the two methods, so now we will find out what is the square of the deviations from the assumed mean, and thereafter we will see that it is coming to 7.66, as you can see in the lower part of the slide. And if you look at the upper part on the left hand side, you can calculate, we are calculating sigma from the arithmetic mean, that is 16.4. The deviations are calculated from the arithmetic mean, and that also gives us 7.66. So this is the actual concept, the step-by-step process of finding out the standard deviation. Right, now we look at another simple example. We have some numbers 10, 11, 12, 13, and 14, and we are given certain frequencies. So we have certain frequencies. Here we will see how the standard deviation is calculated. So in the lower part of the slide, we are first writing down all the numbers, the variables which are given. This is in the first column. You can see 10, 11, 12, 13, 14. In the next column, the frequencies are plotted, and then we are taking the assumed mean, because the deviation we have to find out, and then we have to square the deviations. We have to get the square of the deviations. But the deviations here in this example is from the assumed mean. So looking at the assumed mean, so we are assuming 12 as the assumed mean. So we are taking 12 as the AM, the assumed mean. From there, if you look at the third column, we are getting the deviations. So the first number is 10, and the assumed mean is 12. So 10 minus 12 gives you minus 2. The next observation is 11. 11 minus 12 is minus 1. So in this way, you can see column 3, where we are writing down the value of D, which is deviation from the assumed mean. Here the assumed mean is 12. So therefore, we are getting numbers minus 2, minus 1, and so on. Now we have to multiply these deviations with the frequency. Frequencies are given in column 2. So if you now look at column 4, you get the product of a frequency of 3, and the corresponding deviation is minus 2. So your deviation D is minus 2, and your frequency F is 3. Therefore, FD, the product of frequency and the deviation, comes to how much? Minus 2 multiplied by 3, that is minus 6. Okay, I hope you're able to follow. It is clear to you. Similarly, for the next observation 11, the deviation is worked out, it is minus 1. The frequency is 12, and therefore FD, the product of the frequency and the deviation, comes to minus 12, because it is minus 1 multiplied by 12. In this way, column 4, please look at column 4, you will see that FD, the product of frequency and the deviation, is worked out for each of the variables which are given. At the end, FD, sigma FD is calculated. Please note, for the frequencies given in the second column, sigma F, the total of the frequency, comes to 48, and FD, sigma FD, comes to 0. Now we calculate the square of the deviations. We have the square of minus 2 is 4, minus 1 is 1, and so on. So you can see column 5 calculates the square of the deviations, and the last column, column number 6, is nothing but the product of the frequency and the square of the deviations. That is, it is FD square. And we can see the sigma FD square. If you look at the total of the FD square column, total of column 6, it works out to 48. So therefore, in the lower part of the slide, you can see the final calculation of the standard deviation. It is denoted by the letter sigma. And you can see it is the square root of sigma fd square divided by sigma f minus sigma fd by f whole square. So it works out to 1, exactly 1. So this is first, of course, we have to take the assumed mean. Then we find out the deviations of each of the observations given in the distribution from the assumed mean. So you get di, and then we calculate d square, plus what we do is we get fd, another column where we find out the product of each of the deviation and the frequency. And as you can see, the last column is the fd square column, where we multiply the frequency of each item, each variable. We multiply that by the square of the deviation. In this way, we are able to compute the value of standard deviation. Now, dear students, we go to a bigger example where we have group distribution. So here, this is from the ICAI study material, and we are going through few of the important illustrations so that the step-by-step process. So here we see that certain weights are given and number of persons. That means for each of the categories or classes, 44 to 46 kgs, we have number of person is 3. That means the frequency is 3. Please note that all the classes are continuous, 44 to 46, then 46 to 48, and so on. And we have got the total frequency, which is how much? 80. From here, from this, now let us focus on the solution on the right-hand side of the slide. So you can see the first column where we have all the weights which are given, central tendency, and the calculation of mean. Even before that, when we talked about the statistical description of data, and I was explaining the class limit, class boundary, you may remember we talked about class mark, like the midpoint of every class. So here we have 44 to 46. We are taking the midpoint 45. For the class 46 to 48. So dear students, please once again note that this example, which we are explaining now, is a grouped frequency. So we are having weight categories. There are classes. And now we look at the solution once again. So the second column is where we write down the midpoint of every class. Okay, clear? The third column, the frequencies. Then the fourth column is where we take the assumed mean. Because standard deviation is what? Ultimately, the deviations in the calculation of standard deviation, the deviations are calculated from the arithmetic mean, not from the median, not from the mode. Please remember. On the other hand, mean deviation, as we had discussed earlier, if you look at the explanations for mean deviation, yes, mean deviation can be calculated from the arithmetic mean or from the median or from the mode. But standard deviation, the deviations are calculated only from the arithmetic mean. As a result, as you can see in the earlier examples also, here in the fourth column, we have the column for the deviation. That means the difference of every observation from the assumed mean. Now, if you look at once again the midpoint, column number 2, you have 45, 47, 49, 51, and 53. So here again, if you see 49 occupies the central position, and therefore we are considering 49 as the assumed mean. Accordingly, in column 4, if you see, we have the column of deviation where we are finding out the difference of every value, I mean to say the midpoint, every value which is given in the second column, the difference of the value from the assumed mean. So the first midpoint or the first observation is 45, and we have taken the assumed mean as 49. So 45 minus 49 gives you minus 4. So it is minus 4 here. Next observation is 47. You can see I'm moving my cursor here. 47 minus assumed mean of 49 gives you minus 2. 49 is the third observation. Assumed mean is also 49. So naturally the deviation is 0. 49 minus 49. And the fourth one is 51. 51 minus 49 will give you 2. And the last observation is 53. 53 minus 49 is 4. So now we have got the total of the deviations. Okay. We have got all the deviations in the fourth column. Now we proceed to the fifth column and we find out here we have the d by 2. Why d by 2? Because the class, you can see the class is 46 minus 44, 2. So we are calculating d by 2 to get d dash. And lastly, we take up the last two columns where we have the product of the frequency and d dash. So d dash into f, you get the frequency multiplied by the d dash, which is deviation by 2. And finally, we have fd square, fd dash square. So we get sigma fd dash square is 77. And in the calculation of standard deviation, you can see sigma fd dash square, it is 77. Divided by the total frequency. Total frequency, please see column number 3. Total frequency is 80. So it comes up here. Minus. Now we will see sigma. So sigma fd dash, which is 1. 1 by 80 whole square. So, and then we multiply this by the class interval, that is the class length, which is 2 here. And in this way, we arrive at the standard deviation 1.96 kgs. Here, the unit comes up. Why? Because standard deviation is an absolute measure. Therefore, not just the number, but we also need to include the unit. It could be in kgs, according to the case. It could be in rupees, in currency, in terms of meter, liter, whatever. So this shows the process of calculation of SD. Looking at why it is said that standard deviation is the best measure of dispersion. Before going into that, dear students, let's focus and understand what are the properties, because you may remember that in the last session, I was solving number of problems of the nature of where we have a linear equation y equal to a plus bx, and I was continuously trying to remind you that for arithmetic mean, median, and mode, these three measures of central tendency, these are affected both in case of a change in the origin as well as if there is a change in the scale. But in case of, if you just consider range, if you just take into account mean deviation, and now you can see standard deviation, all these three measures of dispersion, they remain unaffected due to a change of origin, but they will be affected due to a change of the scale in the same ratio. This important point, critically important, I once again request you to note this. And now you can just create a table and you can write that AM, mean, for example, arithmetic mean, or for that matter, say median, any of the measures of central tendency, these are affected both due to a change of origin as well as due to a change of scale. But the measures of dispersion, like range, like mean deviation, like standard deviation, these are not affected in case of a change of origin, but they are affected when there is a change of scale. Now, when you have the relation y equal to a plus bx, as you can see on the slide, and we have done the explanation of this in the earlier session, you must have remembered that, see, y equal to a plus bx is a linear relationship. That means we can plot it on a graph. It will be a straight line. And the intercept, so bx, b is more like the intercept. So when you think of y equal to a plus bx, a shows the origin. A denotes the origin, shift in the origin, whereas b is what? B is an indicator of the scale. So therefore, a very important relation now we are able to understand. If you are given the relation between two variables x and y, And say it says that y equal to a plus bx, and you are also given the standard deviation of x. So x is a xi, just a set of variables. It has its own standard deviation, and x is connected with y through the equation y equal to a plus bx. So in that case, if we know the standard deviation of x, so let us call it sigma x. Sigma denotes standard deviation, so sigma x. Okay. So therefore, if we know sigma x and if we know that y equal to a plus bx, then what will be the standard deviation of y? So the important relation here is sigma y will be equal to b multiplied by sigma x, which means that standard deviation is affected by a change of scale only. It is not affected by a change of origin. So this is a very important property of standard deviation. Also, a similar property which we have observed in the case of mean deviation and range. So please see what are the inferences we draw. So if all the observations assumed by a variable are constant, say they are equal. So there are 5 variables, say 7, 7, 7, 7, 7. 5 numbers, but each, incidentally, they are the same, they are equal. Or you can call it they are constant. What will be the standard deviation? The standard deviation is 0. Why? Because if all the numbers are 7, the mean is also 7. The arithmetic mean will also be 7. If the arithmetic mean is 7 and all the observations are also 7, that means the deviations will be 0. If the deviations are 0, then the square of the deviations will also be 0. Even if you have frequency, if the deviation itself is 0, then there is no need to multiply frequency with deviation because it will also become 0. Ultimately, it means that the standard deviation will be 0 itself. So this is also a very important conceptual conclusion which we draw. Another example is given. This means that if all the values taken by a variable x is k, like I took the example that all the values of a variable is 7. So if all the variables take a particular value k, then the standard deviation is 0. Absolutely. Now we look at the last very important formula of standard deviation, and that is the combined standard deviation. So dear students, in the earlier discussion we had on the measures of central tendency, I had been explaining the process of calculating the combined arithmetic mean of 2 groups of observations. So you may remember if there are 2 groups of observations, N1 and N2. Say there are N1 observations and N2 observations, 2 groups. And the average, the arithmetic mean of the first group is x1 bar, and the arithmetic mean of the second group is x2 bar. Then you can easily find out the combined mean. So what we do, N1 into x1 bar plus N2 into x2 bar divided by N1 plus N2. So this is a very fairly simple formula by which we can calculate or we can arrive at the combined arithmetic mean of 2 sets of data. Why I'm saying this is because just to refresh your mind, to make you recap what you learned, because now we will see a similar approach. This time we are calculating the combined standard deviation. But yes, the formula here is a bit complicated as compared to the combined mean formula. So it is a little, you have to remember, you have to focus, you need to concentrate, you need to understand what are the different terms which are used. Sigma, what is D? So you should be clear that N means the number of frequency, sigma means standard deviation, and D means the deviation. So ultimately, the combined standard deviation of 2 or more groups. You can see here it is given in the study material we can also calculate the combined standard deviation for two or more groups. Please remember, this formula is not limited only to two groups. Even if there are 3, 4, 5, 6 groups, any number, and if you are given the number of observations in each of the groups, if you know the standard deviation of each of the groups, you can very easily, through this formula, you can calculate the combined standard deviation. It is just a matter of time and a few steps which you need to carry out. Otherwise, there is no difficult concept. It is very simple. So here the formula is combined standard deviation of two groups, 1 and 2, denoted by sigma 1, 2. So you can see on the left-hand side, sigma 1, 2. What is the formula? Standard deviation means it's a square root, no doubt about it. Now this time square root of what? So square root of n1 sigma 1 square. Please remember the case of combined mean. There we took n1 into x1 bar. But here we are taking n1 into sigma 1 square. That means the number of observations in the first group multiplied by the square of the standard deviation of the first group. And then we proceed to do the exact same thing for the remaining groups. Accordingly, if you look at the numerator in this part of our discussion, you can see here n1 sigma 1 square plus n2 sigma 2 square. And in this way, we can proceed further if there are more than two groups, but we also have to add the deviation. We need to consider the deviation. So you can see n1 sigma 1 square plus n2 sigma 2 square plus we have n1 d1 square plus n2 d2 square, and then you divide it by n1 plus n2. The denominator is the same even when we calculated combined mean. The same denominator. For two groups n1 and n2, if you find the combined mean in the denominator, you will have the total frequency, that means the total number of observations, that means n1 plus n2, in case you have two groups. So here we see standard deviation of the first group is denoted by sigma 1, and the standard deviation of the second group is denoted by sigma 2. What is d1? You can see n1 d1 square. What is d1? d1 is x1 bar minus x12 bar. And d2 is what? It is x2 bar minus x12 bar. x12 is what? x12 bar is the combined mean. That means d1 is nothing but the difference between the average, the arithmetic mean. There are two groups here, group 1, group 2. There are n1 numbers, n1 variable in the first group. There are n2 variables in the second group. Clear? And the arithmetic mean of the first group is denoted by x1 bar, and the arithmetic mean of the second group is denoted by x2 bar. And please note the combined mean of these two groups is denoted by x12 bar. Please see. So you can see here that we have a subscript x and below that 1, 2. That means it is the combined mean. As a result, you can see the combined mean formula also they have shown that how are we arriving at x12 bar. So therefore, what is d1? d1 means the difference between the arithmetic mean of the first group and the combined mean. What is d2 bar? What is d2? d2 is equal to the difference between the arithmetic mean of the second group and the combined mean. So these are the two things you need to calculate, to understand, to consider. That means here we are calculating the combined standard deviation of two classes, two groups, by considering the individual standard deviation. So we have n1 sigma 1 square plus n2 sigma 2 square, and then we carry out another two additions, n1 d1 square plus n2 d2 square, where d1 signifies the difference between the arithmetic mean of the first group and the combined mean. Similarly, what is d2? d2 is the difference between the arithmetic mean of the second group minus the combined mean. That is it. So you see, it is fairly logical. The best part of mathematics statistics is it is very rhythmical, it is very symmetric, it is very logical. And therefore, now we look at the ICAI study material example 14.2.15. So here we try and see the process for finding the combined standard deviation. We are given certain numbers. There are 60 boy students and the mean and the SD is given. Okay, the mean and the SD of the marks are given. So please note N1 before we see the solution. Just please note down the figures, the data which is given. So we have 60 boy students. So N1 is 60. Mean is given, mean of the first group. So I can write X1 bar, which is the mean of the first group. Here, mean is arithmetic mean. So this is how much? This is 45, fine. And then we have the standard deviation of the first group. So how will I write it? I will write sigma 1 because that is the standard deviation. This is 2. Correct? We now proceed to the next group. You can see the next figures of the second group. This group is of girls. So in the second group, we have 40 girls, which means N2 is 40 and X2 bar, the arithmetic mean of the second group, X2 bar comes to 55 and the standard deviation of the second group, that means sigma 2. So this is how much? This is 3. Fine. So we have got all the important raw material or input based on which we will now process the data and find out what is the combined standard deviation of the entire group. So please note the entire group now has how many? 60 plus 40, 100. So for this, we have to, you can see the solution on the right hand side. First step is to calculate the combined mean. Because unless I know the combined mean, I will not be able to calculate the deviations, that is D1 and D2. Please remember, D1 is what? The difference between the arithmetic mean of the first group and the combined mean. And D2 is what? The difference between the arithmetic mean of the second group minus the combined arithmetic mean. So you can easily understand, dear students, that for finding the combined standard deviation, the first step is to calculate, is to work out what is the combined arithmetic mean. Exactly that is being done here. You can see X bar or the combined arithmetic mean is N1 X1 bar plus N2 X2 bar divided by N1 plus S2. It comes to 49. So the combined arithmetic mean of this total two groups, 60 boys, 40 girls, total 100 people, we get 49. Right? I hope this is clear. You can see the first part of the solution. And therefore, beautifully explained in the CA study material of ICAI, you can see therefore D1 is what? D1 is the difference what? Difference of what? Difference of the arithmetic mean of the first group, which is 45, and the combined arithmetic mean. So you have 45 minus 49, which is minus 4. Similarly, the second deviation, D2, is also figured out, and it is equal to X2 bar minus X bar. And therefore, the X2 bar, we are given 55. The arithmetic mean of the second group, where we have 40 girls, so it is 55. And 55 minus combined arithmetic mean is 49. 55 minus 49 gives you 6. So please see, there are 3 distinct steps. And these type of problems, we will see similar problems have come or are included in the MTP as well as in the ICAI RTP. So this is a likely type of problem which may come, and therefore we should be absolutely clear and prepared to handle any such type of problems. So therefore 3 steps. Step number 1, when you are given these data, first step, calculate the combined arithmetic mean. Step number 2, calculate D1 and D2, that is the deviation. Deviation of what? Please be absolutely clear in your mind, dear students. First deviation, D1, is the difference between the arithmetic mean of the first group and the combined arithmetic mean. D2 is equal to the difference between the arithmetic mean of the second group minus the combined arithmetic mean. So this is your second step. Step 1, calculate arithmetic mean combined. Step 2, calculate D1 and D2. Finally, step 3. Step 3, we just apply the formula. Now we have got all the values. So if you look at the last part of the solution on this slide, we are on slide number 7, you can see the combined standard deviation is worked out. It is equal to n1 sigma 1 square plus n2 sigma 2 square. It is shown by S here, plus n1 d1 square plus n2 d2 square divided by n1 and n2, and it works out to 5.48. So this is very important, the formula, the process, how we are working out. And here we are dealing with two groups. That means altogether we are handling 6 important figures. N1, N2, you get 2 figures. That means the number of observations of the first group and the second group. N1, N2, so 2 figures. Then the third figure and the fourth figure is what? The arithmetic mean of the first group and the second group. X1 bar and X2 bar. And finally, the fifth and the sixth variable or data which we consider is what? The individual standard deviation. That means sigma 1s and sigma 2. So therefore, N1, X1 bar, sigma 1. These are the 3 important parameters of the first group. And in the second group, again, we have the exact mirror image. We have N2, we have X2 bar, and we have sigma 2. Right? So I hope this is clear. You have been able to understand the formula, the logic, and once again, please note that this particular formula of combined standard deviation is based entirely on your understanding of the combined arithmetic mean. So in fact, this formula flows is derived partly from the computation of the combined arithmetic mean. Right? So I hope you are clear. We now proceed to more examples. Example 54, very important for you. It is based on the same formula which we have just discussed in details. 2 samples of size 40 and 50 are given. They have the same mean 53 but different standard deviation. Okay, this might be possible, of course. So there are 2 samples, so we are readily getting the data. We have N1 equal to 40 and N2, the second sample is N2, which is 50. That means total 40 plus 50, 90 observations. The same average, in other words, both these samples have the same arithmetic mean, which is 53. So I will write X1 bar is also 53, X2 bar is also 53. Fair enough. Now the last data which is given is the standard deviation. The individual standard deviation of the 2 samples are 19 and 8, which means sigma 1 comes to 19 and sigma 2 is 8. Right? I'm just writing down the data and explaining what these are the inputs we get from the problem. We have to find out the combined standard deviation. Right? So we apply the exact formula, and first we have written down all the important values of N1, N2, X1 bar, and of course X2 bar, and then we have the sigma 1 and sigma 2. Based on this, the formula we are working out, first you can see step number 1 is to calculate the combined arithmetic mean. So the same formula, N1 X1 bar plus N2 X2 bar divided by N1 plus N2, it works out to 53. Right? And that is what is expected because both the classes have the same mean. So therefore, the combined mean remains the same. Now, second step. So I mentioned that combined standard deviation calculation involves 3 steps. Step number 1, we find out the combined arithmetic mean. Step number 2, we identify D1 and D2 and we calculate the value of D1 and D2. And step 3 is what? Step 3 is the final calculation of the combined standard deviation. So here step 1 is done. We have the combined arithmetic mean of 53. Step 2, we are getting the value of D1 and D2. Please remember once again, D1 and D2 signifies the difference between the individual arithmetic mean of the first group and the combined arithmetic mean. This is D1. And therefore, what is D2? The difference between the arithmetic mean of the second group minus. That means the arithmetic mean of the second group minus the combined arithmetic mean. That gives you D2. So that completes the second step. In the last step, all these values are now put into the formula we know, n1 sigma 1 square plus n2 sigma 2 square, plus we have n1 d1 square and n2 d2 square divided by n1 plus n2. So putting all the values in the equation, we arrive at the combined standard deviation, which is denoted by sigma 1, 2. It comes to 14. So please see the steps, and I hope it is clear to you. We have done the analysis of the formula first, and we have taken 2 examples to further reinforce your concept. So please go through this, and I'm sure you will be able to correctly answer questions based on this formula. We move on to the next example, 14.2.13, critically important example for your understanding of this chapter. If the arithmetic mean and coefficient of variation are given, what is the variance of 15 minus 2x? Okay. Arithmetic mean of x is given is 10. Arithmetic mean gives you 10. Coefficient of variation CV is 40. Question is, what is the variance of 15 minus 2x? So I first have to find out. Now, it is given that coefficient of variation is what? Coefficient of variation is standard deviation divided by the arithmetic mean. Now, the standard deviation is how much? It is given that the standard deviation here, if you see, the standard deviation given is, the coefficient of variation is 40, it is given. So from there, coefficient of variation is 40. So if I write in this way, the standard deviation is denoted by Sx. Because we don't know the standard deviation, we have to calculate. So I write it as Sx divided by x, which is the arithmetic mean, into 100. This gives you 40. Now we know the arithmetic mean is how much? It is given, it is equal to 10. So the standard deviation Sx divided by 10 into 100 is giving you 40. So from there, we are getting the standard deviation Sx equal to 4 from this part of the solution. So now we have calculated the value of the standard deviation Sx, right? Because please remember, the coefficient of variation, which we have discussed already, is an example of a relative measure of dispersion, and it is calculated with using the formula SD divided by arithmetic mean into 100. So here we have applied the same formula, and putting the values, we are arriving at the standard deviation equal to 4. Now, if the standard deviation is 4, question is, we have to find out the variance of 15 minus 2x. Please note, dear students, that variance means it is the square of standard deviation. So step number 1, we know the standard deviation of x, which is Sx, and that is equal to 4. We also know the relation between x and y. It is given y equal to 15 minus 2x. This is of the form y equal to a plus bx, which we were discussing a little while back when we talked about the properties of standard deviation. So therefore, what we get is, please remember that standard deviation is affected due to a change of scale only. Please remember, standard deviation, just like range, just like mean deviation, is not affected due to a change of origin. So only the change of scale we have to consider. Accordingly, if you see here, the change of scale is what? The change of scale is shown by -2. But we will take the absolute value as we have done in case of range, as we did in case of mean deviation. So -2 means we will take the positive value. So it is +2 for us. So we know that the standard deviation of X is 4 and the value of B, the absolute value of B is what? It is 2. Therefore, the standard deviation of Y is how much? Standard deviation of X into B. That means 2. The value of B is 2 and the value of the standard deviation of X is 4. So we get 2 into 4, which is 8. Please note, students, that the standard deviation, I repeat, the standard deviation of Y is equal to 8. That means here 15 minus 2x, as you can see, we take it as Y. So 15 minus 2x for this expression, the standard deviation works out to 8. The question is, find out the variance. We have already noticed and noted earlier that variance is nothing but the square of the standard deviation. In other words, if the variance is given, we can find out the standard deviation, just take the square root. So if it is given that the variance of a series of observations is 36, so what is the standard deviation? It is square root of 36, which is 6. So here, we know the standard deviation, we have to find the variance. So what do? We square it. We get the square of the standard deviation. The standard deviation is 8 for y equal to 15 minus 2x, and therefore the variance is 8 square, which is 64. So this is a very, very important example for your understanding. I hope it is clear. 14.2.13 from the ICAI study material. Now we proceed to the variance. Once again, we see, as we saw, that variance is the square of the standard deviation, and variance is definitely a measure of how far the set of data are spread out from the mean or the average value. And definitely, I'm sure you will agree that lower the value of variance, lower the value of standard deviation, less is the scattering of the data. That means now the data are more concentrated towards the center. They are grouped. They are flocking around the center, around the middle point. This is shown by a low standard deviation and a low variance. Because if the standard deviation is, say, for example, low, the variance also will be low. Now we look at the next point, and that is, so please also do remember that variance is the square of the standard deviation denoted by sigma square. Coefficient of variation we have already seen. Just for your quick recap, the coefficient of variation is a relative measure of dispersion, and it is calculated as sigma divided by x bar into 100, where sigma is the standard deviation, x bar is the arithmetic mean. Please also recollect that because the coefficient of variation is a relative measure, therefore, coefficient of variation is usually expressed as a percentage. No physical units will be included. So the standard deviation of a group of observations, say we are having observations in the sense that we have some height, say the height of children in a class, say it is measured in centimeter. So the standard deviation of this class of students, standard deviation of the height of these students will be definitely is an example of absolute measure. So therefore the standard deviation will have the unit centimeter. Maybe the standard deviation is, say, 12 centimeter or 10 centimeter. So we will write 10 centimeter. But in case of coefficient of variation, it is a relative measure, and therefore it is expressed as a percentage. It will not have any physical units. And the same concept applies when we calculate the coefficient of mean deviation or the coefficient of range. These are relative measures. Please remember. So once again, coefficient of variance or coefficient of variation It is a standardized unitless. Please see the second line here, the second bullet point, unitless measure, and it helps us to compare the degree of variability with regard to two separate distributions, two or more number of distributions where you have different variables, observations, and so on. So the coefficient of variation is also termed as the RSD. What is RSD? The relative standard deviation, right? So I hope you are following, you're understanding. Up till now, we have looked into the details of the standard deviation, the concept of standard deviation, the practicalities, and then we proceeded to discuss about the process of computing the combined standard deviation. We looked at each of the properties of standard deviation, and we noted that standard deviation is always affected by a change of scale, but is never affected by a change of origin. And then, of course, we proceeded to understand variance and the coefficient of variation. Finally, we close standard deviation for the time being by the why it is seen as the best. It is the best measure of dispersion. Why? So let us first look at the advantages. Now, when we look at the advantages, you can see standard deviation is based on all the observations. You may remember when we were calculating standard deviation, we first had to understand that, okay, this is the assumed mean. And then we calculated the deviation of each of the observations given in the table, given in the distribution. All the observations were considered, and we calculated the deviation of each observation from the assumed mean. Please remember, I repeat, each of the observation. This is why standard deviation is based, that is why it is being said that standard deviation is based on all the observations. And no doubt it is rigidly, clearly defined, leaving no room for error, leaving no room for confusion whatsoever. It's very clearly defined. So it is a very good measure of dispersion. Second one, yes, it is amenable to a further algebraic treatment. It has a lot of mathematical properties. So we saw if you know the standard deviation of one group, and you also are given the standard deviation of other, say, second group, we can easily find out the combined standard deviation and variance. They have a lot of mathematical properties. Number three, standard deviation is not much affected by sampling fluctuations. So it's more stable. So the hallmark, right, the feature, the characteristic, the attribute of a reliable measure of dispersion or a reliable measure of central tendency is what? That the measure should be stable. If the dispersion measure itself fluctuates, well, that means it is not stable. If it is not stable, it is not much reliable as well. So standard deviation is easily, of course, I will say for simple classification, it is easily calculated. Yeah, for grouped, where you have frequency, a little difficult, relatively, but the logic is clear why and how we are using which terms, which parameter, when we are squaring why we are squaring the deviations, d square, we know. It is rigidly defined. It is having a lot of mathematical properties. It is not affected by sampling fluctuations, means it is stable, and it is representing the entire observation. Each and every member of the group has to be considered when we calculate the deviation, because without deviation of all the observation from the arithmetic mean or from the assumed mean, we will not be able to calculate standard deviation. So standard deviation is based on all observations, and it is considered to be most appropriate along with the coefficient of variation. Coefficient of variation we have already looked at in details. We have understood the approach, the formula of coefficient of variation, and we also noted that it has a lot of practical applications. Well, disadvantage is very subjective. It is not easy to understand. Yes, Conceptually, it will take some time to understand, but I will also say that, if I compare it with range, range is so easy. Standard deviation, to understand, little time it takes. But the process, the concept becomes clear once you understand mean deviation. So range is the easiest, then you have mean deviation, and then a little more, maybe a little tricky or twisted, you can call it, that is standard deviation. And we will see quartile deviation. So easiest is range, no doubt. Mean deviation is somewhere in the middle, and standard deviation. But once you do a couple of problems, and if you focus and concentrate, and as I always say, that whenever we are analyzing or working out any problem, whether it's from the solved examples or whether I am solving or explaining a problem from the exercise or the MTP or the RTP, I request all the students here to please work out the problem parallelly. Always keep your pen and paper in hand and look at the problem, work it out. Even if you have done it earlier, do it once again. Repetition makes you perfect. Your speed increases. So it is always important to practice as you listen, practice as you see the video. So if you do that, I'm sure you will agree that standard deviation will not be that difficult to understand. But yes, for common people who are not having the background which you have now, your knowledge of statistics, your knowledge of quantitative aptitude. So a common person may not have that background, that knowledge. Yeah, for them it is a bit difficult to understand and calculate. But please see, there are 4 advantages, only 1 disadvantage. That also is very subjective. So overall, we will give a thumbs up to standard deviation. It combines all the winning features of one of the best measure of dispersion. And therefore, the conclusion is, so it is like a review. So you must have seen so many reviews. You go to a hotel or restaurant, you give a review that these are the plus. Okay, the food is great, the service is great. Oh, disadvantage, it's a bit costly. But then you come to the overall review. Right? So the overall review is that it's a fantastic measure of dispersion, the best measure, and what the study material of ICAI says, use it wherever possible. So this is the winner. We have talked about the winner, the champion of dispersion, that is standard deviation, the real hero, you can call it. Now we go to quartile deviation, a very easy, because you already know quartile. So I've kept the easiest one at the end. Quartile, we have already done number of calculations when we were discussing the first unit of chapter 14, the measures of central tendency. And you know what is Q1. There are 3 quartiles, Q1, Q2, Q3. Q1 is given by n plus 1 by 4. Q2 is also known as the median. I hope you remember. And Q3 is given by 3 into n plus 1 by 4. That is Q1, Q2, Q3. Now, what is quartile deviation? You can see the QD, D for deviation. Quartile deviation is given by the formula, a very simple formula, Q3 minus Q1 divided by 2. So this is a formula number 14.2.14. And this is from the ICAI study material. We are strictly following para by para of the ICAI study material, along with the important illustrations and the solved examples. So this is quartile deviation. It is an absolute measure of deviation or dispersion, and it is basically known as, it is a half, 50% of Q3 minus Q1. Naturally, it is known as semi-interquartile range. What is quartile range? Q3 minus Q1. Interquartile range. Semi means you divide it by 2. So please note that the quartile deviation, which is denoted by Q3 minus Q1 divided by 2, has got another name, and that name is what? That name is semi-interquartile range, right? I hope you're following and finding it interesting. Please, once again, I request you, keep your pen and paper ready, look at the problem. I may take some time to explain the steps, but I request you to go ahead, solve the problem, and check your answer with the solution given and see whether your reasoning and the reasoning which I'll be taking up later to explain, are they same? Are they identical? Did you proceed in the right direction? So this is my request to all the students. Now we look at the relative measure, the last and the final relative measure, and we will very soon say bye-bye to this chapter because it's the last formula we are dealing with, the coefficient of quartile deviation. This is Q3 minus Q1 divided by Q3 plus Q1 multiplied by 100. Very similar to the coefficient of range. I hope you remember the coefficient of range. What is range? Range is L minus S, where L is the largest, S is the smallest. What is the coefficient of range? Yes, it is a relative measure and it is calculated as follows: L minus S divided by L plus S. Same thing we do here for the coefficient of quartile deviation, Q3 minus Q1 divided by Q3 plus Q1. Of course, we multiply by 100. It is a relative measure. So this is all about quartile deviation, nothing more so far as your curriculum is concerned. The quartile deviation, therefore, is the product of half of the difference between the upper and the lower quartile. As you recollect, I'm sure you will remember, Q3 is known as the upper quartile. This line says, the statement is that quartile deviation is the product of half of the difference between the upper and the lower quartile. Now we will look at mathematically, we can therefore write Q3 minus Q1 into 1 by 2, into half. Right. Now quartile deviation, that means quartile deviation, yes, please see the next line coming up. It is an absolute measure of dispersion, but the coefficient of quartile deviation is a relative measure of dispersion. Right. Therefore, the coefficient of quartile deviation is obviously used to compare the degree of variation in between two different situations, or maybe when you try to compare between two sets of observations, just as we do in case of different statistical observations, different categories of numbers and distributions. So we try to find out and compare which distribution is more which distribution the numbers are more scattered, which distribution has higher levels of dispersion. So there the quartile deviation coefficient is definitely useful. The properties of quartile deviation are definitely, number one, it is the best measure for open-end classification. We have discussed on the similar line when we had taken up the important topic of median and quartile. So median deals with the middlemost observations. Similarly, quartile deviation, ultimately quartile is what? We look at Q1, Q3. So we are not looking at the ends. So even in case of open-end classification, the quartile deviation works out as the best measure of dispersion. Please remember, a similar question could come in the exam, and the question could be narrated in this way. It can come in this way, that which out of the following is the best measure of dispersion in case of open-end classification. There, please remember, standard deviation will not be the champion this time. This time, in case of open-end classification, the best performer will be the quartile deviation, because quartile deviation does not consider the end, the values in the end. It is also less affected by sampling fluctuations, right? And please remember the last but not the least, the principle, or you can call it the function, the feature, the property of quartile deviation is that very similar to range, very similar to standard deviation, quartile deviation is never affected by a change of origin, but it is affected due to a change of scale and in the same ratio. So similar concept and similar understanding we have already derived in case of standard deviation. Looking at a few problems from quartile deviation, we are taking the first problem here, We have got number of marks. You can see 10 students are given, their marks are given. We need to find out the quartile deviation and also the coefficient. So please note here the question says that we have to find out both the absolute measure, that is quartile deviation, as well as the relative measure, that means the coefficient of quartile deviation. So what do we do? Quartile. That means we first find out Q1 and then we will proceed to find out Q3. As I was mentioning earlier, Q1 is n plus 1 by fourth observation, and Q3, also known as the upper quartile, is 3 by 4 multiplied by n plus 1. That means 3 into n plus 1 by fourth observation. And similar approach and similar processes we have already covered in details when we took up the calculation of median as part of the central tendency portion of chapter 14. So you know that for median calculation for quartile, the golden rule is that we first have to arrange the observations in order of magnitude. That means in order of ascending or descending order, in order of size, value. Okay. So here we have done it in the ascending order, and accordingly, we are getting the first quartile, which is n plus 1 by fourth observation. And you can see the calculations given, it works out to 46.5. Then the next step is to take up the third quartile, also the upper quartile as we call it, 3 into n plus 1 divided by fourth observation. You can see here, it boils down to 8.25th observation, and accordingly, it has been worked out as 67.5. So now we know Q3, we know Q1. So therefore, we get the semi-interquartile range, also known as the quartile deviation. What is the formula? Q3 minus Q1 divided by 2. So we have Q3 67.5, Q1 is 46.5. So we get the quartile deviation, and that is Q3 minus Q1 by 2. It works out to 10.5, as you can see. So now we have got the numerator, and as we know, we have to find out the coefficient of quartile deviation as well. And therefore, when we look at the coefficient of quartile deviation in the numerator, we have Q3 minus Q1, and in the denominator, we have Q3 plus Q1. We know Q3 and Q1, so Q3 minus Q1 comes to 10.5, and you can see Q3 plus Q1 will work out to how much? 67.5 plus 46.5. So therefore, once you put it in place, we get the coefficient of quartile deviation, that is Q3 minus Q1 divided by Q3 plus Q1. We are getting 18.42, but please do note, this is a relative measure of quartile deviation. It's a relative measure of dispersion. That means it is characterized by a percentage. So this is the numerical example of both quartile deviation, as well as we have been able to explain the process of calculation of QD, quartile deviation, plus we have looked at the relative measure calculation, that is the coefficient of quartile deviation as well. We take the second very important problem on QD, quartile deviation. It is given, you can see in the lower part of the slide, the QD, the quartile deviation of X is given, okay, this is 6. And the linear relation between X and Y is also given. Please see it is shown as 3X plus 6Y equals 20. We need to find out the quartile deviation of Y. We have already noted that the quartile deviation and standard deviation and range of course, mean deviation, they are all affected only due to a change of scale. They are unaffected, they are not affected due to a change in the origin. Therefore, here the quartile deviation of Y will be equal to the absolute value of B. y equal to a plus bx. So we get the absolute value of b, and we simply multiply that by the quartile deviation of x. So here, 3x plus 6y equal to 20. So if I just transpose 3x on the right hand side, I will get 6y equal to 20 minus 3x. We have 6y, that means the coefficient of y is 6. But I need to get the equation should be in the form y equal to a plus bx. So I remove a 6. It goes to the denominator on the other hand. So therefore, the equation now becomes y equal to 20 by 6 minus 3x by 6. In other words, I get the value of b, and the value of b is minus 3 by 6. But for the purpose of calculation of the quartile deviation of y, we shall only take the absolute value of b. The actual value of b comes to minus 3 by x, but we will take the absolute value, so we will take the positive value, 3 by x, plus 3 by x. Plus 3 by x means half, 1 by 2. And we know that the quartile deviation of x is 6. So what is the quartile deviation of y? It is b, absolute value of b, multiplied by the quartile division of x. That means half into 6. 3. The answer is 3. So this is what we have in quartile deviation. Simple, easy to understand, and only request to you, please remember the formula. And the more problems you solve, you don't need to actively remember the formula. It somehow your brain will capture it unconsciously. It will become part of your reflex. You don't have to actively remember. It will just flow. When you see a problem, you will just be able to recollect the right formula. Now we move to MCQ set A. We are on slide 13, and we take the first question, number 9. Few important questions we have taken. Which measure is based on only the central 50% of the observations? Yes, central 50% means semi-interquartile range. That means Q3 minus Q1 by 2. So obviously it is quartile deviation. Option B is the right answer. Number 10, which measure of dispersion is based on all the observations? Okay, on all the observations means, well, all the observations, yes, mean deviation, standard deviation, quartile deviation. Then we have A and B, but not C. So I will go for option B, because quartile deviation is not based on all observations, but mean deviation and standard deviation they are based on all observations. That means both mean deviation and standard deviation, they are correct. So here, out of the 4 options, we will go for option D. Right? I hope you're able to understand. We take the next question, the appropriate measure of dispersion for open-end classification. Well, needless to mention, we discussed this a little while back. Open-end classification, automatically it will ring a bell in your mind, and you will immediately catch the secret of this sentence. You will understand that, yes, open-end, that means that classification, that measure, which extreme. Definitely, this is only possible in case of medians and quartiles. So question number 11, obviously it is quartile deviation. 13th question, which measure of dispersion has some desirable mathematical properties? Okay, so yes, standard deviation is obviously having a number of important mathematical properties, but please do appreciate that even for quartile deviation and mean deviation, yes, they all have important mathematical properties, and they are rigidly defined. Yeah, there will be some differences in the degree of difficulty of understanding the concept. Maybe standard deviation is a bit difficult to understand initially. Of course, standard deviation comparatively is a little more difficult to calculate, but there is absolutely no hesitation to say that all these 3 examples which are given, if you see, they have certain desirable properties. But if you look at which measure of dispersion, which has the maximum number of mathematical properties, obviously it will be standard deviation. Mean deviation has certain disadvantages, but still if you look at overall perspective, each of them have certain, because they are rigidly defined and they have certain mathematical properties, no doubt, but the best answer would be standard deviation, because standard deviation undoubtedly has the maximum advantages. 14th question, if the profits of a company remains the same for the last 10 months, then the standard deviation of the profits will be what? Well, this shows that if the profits are identical, that means the profits are constant. And we have already dealt with this type of statement, that if the variable assumes a constant value, obviously the standard deviation will be 0. So question number 14, the answer is 0. 16th question, a shift of origin has no impact on which? A range, yes, no impact. Mean deviation, no impact. Standard deviation also, there is no impact. So obviously, 16th question, we will see. Option D, please have a look at option D. It says all these and quartile deviation. Yes, even quartile deviation will experience no effect due to a change of origin. So we will go for option D, question number 16, we will click number D. And that is the logic, the reason why we are opting for D. Proceeding to the 20th question, if all the observations are increased by 10, what will happen? Let us look at the options given. This is question number 20 of the exercise and the MCQs. Please do observe that several questions are based on principles, on the theoretical part, on the technical part. And there are obviously a lot of questions on numbers where you have to calculate the standard deviation or the combined standard deviation, or maybe you have to find out the coefficient of variation. So please be ready to handle and deal with all types of problems, both theoretical as well as the numerical problems. Here, if the observations are increased by 10, what will happen? SD would be increased by 10. Mean deviation would be increased by 10. Quartile deviation would be increased by 10. No, doesn't make sense, because we have already seen that none of these measures of dispersion are affected due to a change of origin. What you see here, if the observations are increased by 10, by 5, by minus 20, whatever be the number, ultimately we are talking about changing, increasing or decreasing the observation by a factor. Here it is 10. So this is signifying a shift in the origin. We know that all the measures of dispersion, neither of the measures are affected by a change of origin. So therefore, option D is the right answer. We take questions from set B of the exercise. Number 14, here we have some numbers, numerical questions. Question number 1, if the SD of x is 3, what is the variance of 5 minus 2x? So lovely question. We probably had explained step by step a very similar question in the last few minutes. So it is given y equal to 5 minus 2x, step by step. We will go. We are not looking at the answer or the solution. We just do it on our own. So we write y equal to 5 minus 2x. And therefore, this is of the form y equal to a plus bx. Here b is minus 2. But we know for finding out the variance of y, we will consider the absolute value of b. So here b is carrying a value of minus 2, but we will consider the absolute value. That means it will be the positive value plus 2. So we will take it as 2. And now we know SD of x is 3. So therefore the SD, the standard deviation of y, will be what? B multiplied. Here b is the absolute value of b multiplied by the standard deviation of x. So I am getting 2 into 3, that is 6. This is the standard deviation. But the twist is, question says, what is the variance? So sometimes we may not see the entire question. Back of our mind, we are thinking that, oh, this is a question to find out the standard deviation. No, it is the variance. So once you get the standard deviation of y, which is 6, please very carefully, in a very cool, calm, composed manner, see the question once again. It is variance. So if I know that the standard deviation of y is 6, what is the variance of y? It is square of the standard deviation. So 6 square, 36. So option A is the right answer. We proceed to the next one, 15th question. If x and y are related by the equation is given 2x plus 3y plus 4 equal to 0. The standard deviation of x is given. This is 6. So I will write sigma x is 6. What is the standard deviation of y? Here it is not a question on variance. It is a direct question on SD. Okay, so we will just rearrange the equation. So 2x plus 3y plus 4 is 0. Please write, please transpose 2x on the other side. So you get 3y equal to minus 4 minus 2x. And therefore, y is equal to minus 4 by 3 minus 2 by 3x. That means the value of b here is, I'm getting minus 2 by 3. We have to find out the SD of y. SD of y is equal to what? The absolute value of b multiplied by the SD of x. SD of x is sigma x, which is 6, which is given. And the absolute value of b is 2 by 3. So if I multiply 2 by 3 and 6, I am getting 4. So the standard deviation of y is 4, which means option B is the right answer. Question 15 we have done. Number 16, the quartiles of a variable are 45, 52, and 65. What is the quartile deviation? Wonderful question. You are given the 3 quartiles, Q1, Q2, and Q3. Well, we need to find out the quartile deviation. Okay, so we know quartile deviation is also termed as the interquartile range, right? We were discussing that a little while back, and you are given Q1, Q2, Q3. So what we do, Q3 minus Q1, let us try. So Q3 minus Q1 shows the difference between the third quartile and the first quartile. You know, consequently, just to repeat, just for your reference, Q3 is also is known as the upper quartile, and Q1, which is 45 in this case, signifies the lower quartile. Q2 is the median, please remember. So therefore, here what we get is the Q3 minus Q1 comes to 65 minus 45, which is 20. And now we have to find quartile deviation. So it is half of this difference. So half of 20 is how much? 10. Well, I will go for option A, which is 10, right? So I hope it is clear you were able to understand the principle, the logic, and the step-by-step reasoning in order to solve the problem and arrive at the right answer. Question 17, we are taking x and y related by the equation 3x plus 4y equal to 20. So we rewrite the equation as 4y equals 20 minus 3x, fine. And therefore, y equal to 20 by 4 minus 3 by 4x. So the value of b here becomes 3 minus 3 by 4. We will consider the absolute value. Absolute value of minus 3 by 4 is only 3 by 4. That means we assume the default positive. By default, we take the positive value. So it is 3 by 4. It is given that the quartile deviation of x is 12. Okay, so b, I'm getting the value, the absolute value is how much? I'm getting 3 by 4. I multiply that by the quartile deviation of x, which is 12. So I'm getting 3 by 4 into 12. That gives me 9. So the answer should be that the quartile deviation of y is 9. Option D, if you look at the options given, we will take the last option. Question number 8, if the relation between x and y is 5y minus 3x equal to 10, and the mean deviation about mean is 12, what is the mean deviation of y about the mean? So now that we are concluding the chapter 14, the entire chapter on the measures of central tendency, which was unit 1, and then measures of dispersion, which was unit 2. So having completed, we are now dealing with questions which are actually composite. So they relate to mean deviation, they relate to range, they relate to QD, right? Entire all parts of the chapter. So question number 8, same process. So 5y minus 3x equal to 10. So we write 5y equal to 3x plus 10, which means y is equal to 10 by 5 plus 3x by 5. This is of the form y equal to a plus bx, and here b is 3 by 5. Okay, if b is 3 by 5 and it is given that the mean deviation of x is 12. The mean deviation of x is 12, and the value of b I'm getting is how much? I'm getting, I'm getting 3 by 5. There is no confusion of negative sign here, because once you transpose 3x on the other side, say minus 3x becomes plus 3x. So you are just getting the value of b as 3 by 5. And therefore, the mean deviation of y is equal to the mean deviation of x multiplied by b, the absolute value of b. Here, the mean deviation of x is 12, and the value of b, the modulus or the absolute value of b, is 3 by 5. So I just multiply these two numbers, 12 into 3 by 5. So this gives me 36 by 5. And if I work it up, it comes to 7.2. Option A, therefore, is the right answer. We now move on to the 9th question. We have, we are taking the next question now. This is, if two variables x and y are related, very similar question. And we have to find the coefficient of mean deviation here. So what we do, we are given the mean of, the arithmetic mean of x. Please remember that the arithmetic mean is affected both by a change of origin as well as by a change of scale. Accordingly, we have first worked out the mean of y, and you can see this comes to 5 by 3. Right? We have just transposed 2x on the other side, 7 on the other side. So from the equation given, please try it out. You will see that here the equation we can take the next step like this. 2x plus 3y minus 7 is 0. So therefore, we can write 3y is equal to 7 minus 2x. That means y equal to 7 by 3 minus 2x by 3. That means here the value of b is minus 2 by 3. Minus 2 by 3. Now here we know that for the purpose of calculating the mean of y will be affected both by a change of origin and by a change of a scale here. So it comes to 5 by 3. Now from in the next step, we are given the mean deviation of x, that is 0.3. So we easily calculate the mean deviation of y. Of course, we know the mean deviation of y will be what? It will be the absolute value of b multiplied by the mean division of x. So we get 1 by 5. Finally, in the last step, we find out the coefficient of mean deviation for y. It works out to 12. So this means it is option number B, option B. Okay. Right, so we are doing a number of questions. We take the 19th question now. So we are given x and y are related by y equal to 2x plus 5, and the SD and the arithmetic mean of x are given. What is the coefficient of variation? So here again, we will use the same approach. We are given x and y are related, y is 2x plus 5, and the SD and AM of x are given. So if the arithmetic mean of x is given, so we need to find out first the arithmetic mean of y. And the equation is y equal to 2x plus 5. The arithmetic mean of x is 10. So therefore, the arithmetic mean of y will be how much? 2 into 2x plus 5. So it will be 2 into the arithmetic mean of x plus 5. That means 2 into 10 is 20, plus 5 is 25. I'm getting the arithmetic mean of y comes out to 25. The next question, the next part of the solution is, we know the standard deviation of x is 5. So what is the standard deviation of y? Now we know the standard deviation is affected only due to a change of scale, and here scale means b, right? Y equal to a plus bx. Here b signifies the slope, the gradient you can call it. It also signifies the scale. So the scale here is 2, and if the standard deviation of x is 5, then the standard deviation of y will be the absolute value of b multiplied by the standard deviation of x. So what I'm getting is the standard deviation of x is 5 and the value of b is 2. So the standard deviation of y works out to 5 into 2, that is 10. Right? So we got the arithmetic mean of y as we have got it as 25, and the standard deviation of y is 10. So what is the coefficient of variation of y? Now we know the coefficient of variation is given by the formula standard deviation divided by arithmetic mean into 100. So we have derived the standard deviation of y. The SD of y is 10. So I write 10 in the numerator, and the arithmetic mean of y, we worked it out. It is 25. So 10 by 25 into 100. So that means I get 40. I hope you have got 40 as well. Option C, therefore, is the right answer. We now proceed to handle some questions from the additional MCQ. First question, which measure of dispersion ignores the positive and negative signs of the deviations? Okay, so if you recall the earlier discussion, there is one measure of dispersion where we have ignored the positive and the negative signs. We only took the absolute value of the deviation. If you remember, this particular measure is the second one, mean deviation. In case of mean deviation, we take the absolute measure of the deviation from the mean or from the median, as the case may be. So question number 1, option B. Question number 2, if all observations in a data set are multiplied by a constant 5, what happens to the new standard deviation? Okay. So we know that the standard deviation is affected by a change of scale. Now here, if all the observations are multiplied by a constant 5, that means there is a change of scale by 5. So the new standard deviation will be affected because of this. What is the scale given? The scale is 5. So therefore, the new standard deviation also will be multiplied. How will you get the new standard deviation? It will be equal to the old standard deviation multiplied by 5. So ultimately what will happen is option C, the new SD we will get by multiplying 5 with the current SD. Question 2, option C, I hope you're clear with this. Number 3, what does a standard deviation of 0 indicate about the data points? So lovely question. If the standard deviation is 0, what does it indicate? Let's see the options. The data has extreme variability. No. The data points are all identical. Yes. So question number 3, if the data points are all identical, same number, same constant, it's a constant. Well, then we will say SD equal to 0. So question 3, option B is the right answer. Question 4, if you add a fixed value of 10 to every single number in a data set, what happens to the range? So please see some of these additional MCQs. Very intelligent question. It will test your concept. So yes, for question number 4, if you add a fixed value of 10, that means if you shift the origin by 10, all numbers in a data set, we are shifting them by 10. What happens to the range? What will happen? Will the range change? No. Range we know is unaffected by a change of origin. Range is always affected or only affected by a change of scale. So here this concept of adding a fixed value of 10 actually signifies that we are shifting the origin by 10. So therefore, this it has absolutely no effect on range. It will also have no effect on mean deviation or standard deviation or even QD, quartile deviation. Question number 4, option B, I will go for option B, right? So I hope it's clear to all of you. We now take questions from the AQB. We are on slide number 16, and we will take questions from AQB. Mean is of how many types? Well, mean is of how many types? We have arithmetic mean, geometric mean, and harmonic mean. So I'll go for 3. So option 1. Second question, number 7, we are taking the algebraic sum of deviations of observations from their arithmetic mean is what? It will always be 0. Question number 7, we will take the last one. Third question, we are taking question 10 here. This is number 3 in the sequence. The GM of 8, 4, and 2 is how much? So 8, 4, and 2. So we know the GM, the geometric mean, is what? The nth root of the product of these numbers. So, okay, 8 into 4 into 2. So that gives us 64. And we need to find the nth root here, n is 3. So the cube root of 64, which is 4. So question number 10, option A. 14th question, value of the middlemost item when they are arranged in order of magnitude. So I guess, dear students, you will appreciate that all these questions, it's also refreshing your memory, because this chapter 14 is pretty long. We have spent 4 sessions. ICAI has given us 4 sessions, because to cover in detail the measures of central tendency, that is unit 1, we had 2 sessions, and for dispersion again 2 sessions. So chapter 14 is a very large chapter, new concepts, a lot of new formula, new understanding. Of course, it deals a lot with both the central tendency and the dispersion, the scattered nature of data in a distribution. So many questions will now be there from both unit 1 and unit 2. So this is a question on measures of central tendency. Now, value of the middlemost item when they're arranged in order of magnitude is what? Well, it is the median. So I will go for option number D. This is 14th question. 17th question, the value which occurs with the maximum frequency, open and shut case, absolutely the mode. So 17th question is B. 22nd question, mode of the observations. Okay, let me see the observations. Please note, dear students, that in the given observation, question number 22, what we see is that the number 4 repeated with the highest frequency. Let's see how many times 4 is repeated. 1, 2, 3, 4, 5, 5 times. Obviously, 4 is therefore the mode. Option D is the right answer here. We proceed to the 36th question. Deviation may be positive or negative or 0. It's true. Yes, deviation can be both positive and negative. It can also be 0. Yes. 42nd question, the arithmetic mean of 8, 1, and 6. Okay, 8 plus 1 is 9, 9 plus 6 is 15, 15 divided by 3 is 5. So, okay, 42nd question, answer is A, 5. 58th question, the class in which the mode belongs. Well, this is known as the modal class. That means that particular class which has the highest frequency will be the modal class. So 58th question, option number is C. Right. Okay. 62nd question, relation between mean, median, and mode. Oh, lovely. The golden rule, just like we have the golden rules in accounting. So this is just my personal perception. These are the golden rules of statistics, the golden formula. So we remember the relation between mean, median, and mode. Which one is the correct answer? So you will definitely agree that the correct answer is mean minus mode equal to 3 into mean minus median. So option D is the right answer in this case. The 70th question, dash is the value of the variable corresponding to the cumulative frequency n by 2. So when you have the cumulative frequency n by 2, obviously we are talking about the middle number, that is median. So question 70, option C is the right answer. 93rd question, the 10th percentile is equal to what? We know the 10th percentile means we are 10th percentile, means percentile means we are dividing the entire distribution into 100 parts, because quartile is 4, decile is 10, percentile is 100. 10th percentile means what? It means 10 by 100. That means 1 by 10. 1 by 10 means it is the first decile, D1. I'm sure you will remember this. You must have quickly recollected, and you must have given the right answer. So 93rd question, option A. We move to the 94th question. 50th percentile is known as what? 50th percentile means 50%. If I say I got 50% marks in the aggregate, okay, in an exam, okay, that means here we are talking about 50, middle. Middle means median. So 94th question, obviously we are taking option D. 136th question, dash deviation is called semi-interquartile range. We have done the full analysis of this particular semi-interquartile range. It is the quartile deviation, QD. Q3 minus Q1 divided by 2. Please remember. 141st question, coefficient of variation. Standard deviation, okay, divided by mean into 100. Yes, it's correct. Obviously correct. So option is true. 147th question we are taking now. We are on slide 18. And yes, we are taking 147. A measure of central tendency tries to estimate what? Obviously the central value. So 147th question, we will click option A. 148. Measures of central tendency are known as what? Well, measures of central tendencies, we call them average. The normal term in everyday life, we use the term average. So that is basically the best way to denote a measure of central tendency. 229th question, the square of standard deviation is known as what? Oh, well, lovely. We have discussed this. The square of standard deviation is variance. And therefore, the square root of variance is the standard deviation. 229th question, we will go for option A. 236. For values lying close to the mean, the standard deviation are what? Okay, all questions are very interesting, and they will test our understanding of this chapter, and very similar questions keep coming in the exam, right? Please go through the past year's question papers. You will definitely appreciate that these questions given in the study material exercise set A, set B, the additional question bank, we are covering number of questions from both unit 1 and unit 2, central tendency as well as dispersion. And then, of course, we will go to the MTP, RTP as well. Just wait for a few seconds before we do that. But for 236th question, if the values in a distribution are close to the mean, that means they are scattered very close to the average, to the maybe the arithmetic mean. In that case, the standard deviation will be less, because the deviation we calculate. How do we calculate deviation? Deviation means the difference between each observation and the mean, and therefore the arithmetic mean. Therefore, the standard deviation will be less, small. Option B is the right answer. Now we move to MTP, and we take the first question here. An analysis of monthly wages of wages paid to workers in two firms. So lovely question. Seems like some comparison. Let me just take a fresh page. Analysis of monthly wages paid to workers in two firms. You are given the mean wage in firm A with a variance. Please note, variance is given, not the standard deviation. Variance means it is a square of standard deviation. So for firm A, I will write average XA bar is 5,000. If variance is 81, that means sigma, standard deviation, is square root of 81, which is 9. Firm B has a mean wage of 4,500. XB bar is 4,500. Variance is 64. That means the standard deviation sigma B is square root of 64. That is how much? 8. Oh, lovely question. Which firm shows greater variability in individual wages? The best way to calculate this would be by the process of the coefficient of variation. And you know the coefficient of variation, as we have discussed, is the SD divided by arithmetic mean into 100. So if I do it, first of all, as I was explaining, that we have got the standard deviation here. For firm A, it is 9. For firm B, it is 8. Firm A is 9, as I said, because square root of 81. Now we will calculate the CV, the coefficient of variation of firm A. SD of A divided by mean of A. SD is given, how much is given? SD is 9, we have got it. Mean is given. Mean is 5,000 into 100. So we will get a value here. And then we have the similar calculation for the coefficient of variation for firm B. And we do that, we are getting 0.1777. And therefore, the question is, which firm shows greater variability? Of course, both are very close to each other. However, mathematically, of course, we will say that firm A has a higher variability in individual wages. And therefore, we will take option A as the right answer, firm A. Correct option is firm A. Right, I hope you understood this step by step. We go to the second question now. Question 2 says, if the highest value in a data set is 85 and its coefficient of range is 0.6, what is the lowest value? Options are given. Right, so we are dealing with absolutely a good number of questions of different types of variety. Some are absolutely easy, some a little bit of thinking required, and some are little computation like the one we have done it, the first question on this MTP series. This requires some calculation. Question 2, the highest value is 85 and the coefficient of range is 0.6. What is the lowest value? So we will take the lowest value as S, S signifying smallest s. Highest value L is 85. That means coefficient of range, we know this is L minus S divided by L plus S into 100. Here L is given, the highest value is 85. So we will write the equation 85 minus S divided by 85 plus S into 100 gives us 0.6. Okay, so in other words, the ratio 85 minus S divided by 85 plus S is 0.6. On a percentage, it comes to 60%. So from this equation, if you work it out, you will get the lowest value and it will work out to the smallest value comes to 21.25. So in this example, in this question, option B will be the right answer. So same formula, as I said, H highest minus lowest divided by highest plus lowest into 100. That gives you the coefficient of range. We move to the third question in the MTP. The mean deviation is minimum when it is calculated about which statistical measure? Well, this is absolutely option D, median. We discussed it multiple times that the mean deviation is always minimum when it is calculated from the median. Fourth question, what is the standard deviation of the following data set? Well, all the numbers are same, 7, 7, 7, so it's constant. Therefore, standard deviation is 0. Fourth question, option C. This is just by inspection you can do. Fifth question in the MTP. If the variance of a variable is 9, please note variance. That means standard deviation. The standard deviation works out to 3. Question is, what is the variance of a new variable which is defined as y equal to minus 3x plus 5? So the variance of x is 9, which means sigma x, that is standard deviation, is square root of 9, which is 3. We also know that the standard deviation of y is equal to the standard deviation of x multiplied by the absolute value of B, and B is the scale. Here, the value of B, the absolute value of B comes to 3. And the standard deviation of X is also 3. Please note, standard deviation of X is 3, and the absolute value of B is also 3, which means that the standard deviation of Y is 3 multiplied by 3, which is 9. If the standard deviation of Y is 9, the question is, what are they asking? They're asking the variance. If the standard deviation of Y is 9, then the variance of Y is the square of the standard deviation. That means 9 squared, it is 81. So question 5, we will go for option C. I hope you can see the working out here. Now we come to the last part, the RTP. We have the RTP questions now. RTP questions September 2026. 19th question, appropriate measure of dispersion for open-end classification is what? SD? No. Mean deviation? No. QD is the right answer. Yes, if you have guessed it correct, you must have got the right answer. It is the quartile deviation, because for open-end classification, it is always the quartile. Why I've given one line I've added, it only looks at the middle. That's why, it's known as the semi-interquartile range. Q3 minus Q1 divided by 2. Right. So here, open ends do not ruin the calculation of quartile deviation. The 24th question says a variable is dash if it can assume any value in a given interval. Well, this answer is continuous. A variable like could be the temperature of a day, the height of a person, okay, the profit of a company can assume any value. It could be fraction, it could be positive integer, it could be negative, it could be 0 as well. So it's a continuous. These are examples of continuous. A variable is dash, a variable is continuous. Option 20, question 24, option B. And the last one I guess we have is find the coefficient of range for these numbers. Okay, a coefficient of range. Let's quickly see the numbers and try to figure out. Coefficient of range means the L minus S, largest minus smallest, divided by largest plus smallest into 100. The largest number in this series is 95, as I get it here. And the smallest number, okay, is, I guess, 55. 55. So in the numerator, I have 95 minus 55. In the denominator, I have 95 plus 55. So that gives me how much? In the numerator, I get 95 minus 55, that is 40. In the denominator, I get 95 plus 55, that is 150. I multiply this, means I'm getting 40 by 150 to 100. If you work it out, comes to around 26.67, right? So it's around 26.67 option. Therefore, the correct answer would be around close to 27%, exact 26.67. That is the process we have taken. So with this, we come to the end of this long chapter 14, but I hope it was a beautiful journey. We understood some very important principles, and both central tendency and, of course, the dispersion measures. Please remember arithmetic mean, geometric mean, harmonic mean, median, quartile, decile, percentile, and then we went to mode. And we observed that mode for a given distribution, there might be 2 modes, there might be multiple modes, even there may not be any mode as well. And then we moved on to the unit 2 of chapter 14, delving deep into the measures of dispersion, starting first with the easy measure of dispersion, that is range, and we took up the coefficient of range. Please remember each of these formula. And you could see we have done a number of questions from the set A, set B, additional question bank, additional MCQs, MTP and RTP. And I hope you will appreciate that questions can come even from the theoretical or the conceptual part. It may not always be from the numerical portion. So I request once again all dear students to please go for a balanced approach. All important discussions we had on the theoretical part, on the technical part, on the features of each of the measures of dispersion, the properties, the advantages, the disadvantages, plus the formula. Please be inclusive. Do not go for please don't go for any type of selective study. Please embrace each and every point. Chapter 14, as Dr. Ravi sir said in the very beginning, very significant chapter. It is the heart, if you see, of statistics because it contains both dispersion as well as the central tendency. And you remember accordingly, we moved on from range to the coefficient of range. Then we saw the mean deviation. We did number of problems on the coefficient of mean deviation, and then proceeding today to standard deviation and analyzing, understanding quartile deviation. And finally, a quick summary for you. It might be of some use to all of you. I thought of, before we close, we just have a quick summary. Range, please see the formula, largest minus smallest. Focus is on the extreme limits. As you can see, the main advantage is it is extremely easy to calculate. The disadvantage is you can understand extreme value, outlier, automatically the range gets distorted. Okay, so that is the main disadvantage. Moving to the QD, quartile deviation, also known as semi-interquartile range, shown by Q3 minus Q1 by 2, exclusively deals with the 50%, middle 50% of the data, right? Please see the main advantage, excellent for skewed data or for the open-end classes, right? We discussed this in our course of our presentation. Disadvantage is ignores 50% of the data set. Absolutely correct, because it is only concerned on the middle 50%. Mean deviation, please remember, it's the average absolute distance. And here for the deviation, we ignore the sign. We will only take the absolute values. Simple to understand, all data points are equally considered. But yes, it ignores negative sign, as I said, and therefore it has some obvious shortcomings, right? Standard deviation, the champion of the dispersion chapter, chapter 14, unit 2, obviously the hero or the heroine or the main crowd puller, given by square root of sigma x minus x bar squared by n. It shows the average distance from the mean. Please remember, the standard deviation is the square root of variance, and it is sound as a mathematical measure. It is best for the normal data, and of course, it has a series, a host of applications in real life applications in commerce, industry, and only one disadvantage, as we saw, that it is sensitive to extreme outliers, not to the extent of range, but yes, it will have certain impact. And of course, people might feel that, yes, standard deviation is a little difficult to understand. But yes, with more and more practice, standard deviation formula will become second nature for all of you. And effortlessly, you will be able to find out the SD or the variance from a given set of numbers. So on that note, we also did the questions from exercise 14. Set A, set B, the AQB, the additional question bank, a number of questions given in the ICAI study material, requesting every one of you to please do as many from them as possible. And at the end, of course, we have taken some important questions from the NTP, the RTP, as well as the latest RTP September 2026 questions of the ICAI. So on that note, I will thank you once again for your continued presence, your efforts, your focus, concentration. I hope chapter 14 has been a good experience. I think I've learned a number of new formula. It was a refresher for me as well. Got the opportunity of solving a number of problems, explaining. So this reinforces your concept, and it's a critically important chapter for the exam. And I hope you get the right foundation now. And based on this, we will move on later in the next session on probability. Probability, very interesting. part of statistics and then probability distribution, there you will again recall our discussion. There we will continuously refer to variances and dispersion. So you will see even in the chapter on probability distribution, we will refer back to the concept of dispersion, which we have been able to achieve through these sessions of the LVC. So thank you once again. I request the tech team, the tech support team, sir, to kindly conclude the session, and requesting all students to keep practicing and go through the video once again. See you next day with probability. Thank you. Thank you, sir.